Hi everyone, this is our final project presentation for DSBA 6190 with Cal, Elvis, Jake, and Pooja. For our final project, we decided on New York City Airbnb predictions, and we will go ahead and start with a brief introduction of our dataset and goals. Many know that Airbnbs have been an efficient option for many people as it offers cost-saving accommodations in a specific area. With that being said, we found a New York City Airbnb dataset on Kaggle that we were interested in exploring further. This dataset includes recent listing activities and metrics in New York City as of 2019, so the data is fairly fresh. At first glance, the features of the dataset are represented in the table on this slide, ranging from host ID, latitude and longitude, price, neighborhood, etc. With this information in mind, we determined that individuals would benefit from a model that can quickly and accurately predict the cost of an Airbnb, given certain features that they would prefer. So our goal for the machine learning side of our project was to have an efficient model that would accurately predict the price of an Airbnb for individuals to have a great experience. After deciding on our target, our first step was identifying which features would best help us make predictions, grant better results, and better performance. After careful consideration, we decided on 6 features that would help predict the target feature price. That would be the primary neighborhood type, specific neighborhood, the room type, number of reviews per month, and the availability out of 365 days. We then wanted to explore our data with the features that we had selected, just to see the distributions, the 5 statistical summary, correlations, and density through various visualization techniques. This gave us an idea of what we would be working with and try to identify any predetermined patterns that we could fix prior to the modeling phase. From the visualizations, all results seemed to be alright. There were very few discrepancies as far as noise, outliers, or human errors, so that was good. We then moved on to the pre-processing stage, where since we set the features we selected did contain some categorical ones, we had to hot encode those using dummy variables. We also had to check for any null or missing values, and fortunately with the features we had selected, there was no case of that. In addition, we went ahead and executed the train and test split preparation with an 80-20% split for training the model. And prior to fitting any models, we scaled training and testing data using the standard scaler in the pre-processing package in Python. After exploratory data analysis and pre-processing, we were able to refine questions that we had in the beginning. Some research questions we had in mind were: 1. What is the most efficient model to accurately predict Airbnb prices in New York City, given pre-selected features? 2. What patterns did we detect in predictions? What features cause a certain price range? 3. Does less availability automatically mean that the Airbnb is in high demand or very expensive? And 4. For future purposes, what features should an individual look for if they prefer an Airbnb in the lower price range, vice versa with a higher price range? To start off with the modeling process, we printed out a decision tree to showcase the varying metrics of each feature with the mean squared error. It started off with the feature that could eliminate the most possibilities, so it started out with the room type and went from there. As exemplified in this slide, we implemented various models on the testing set to see the metrics of each model. We tried linear regression, decision tree, KNN, random forest, support vector regressor, gradient boosting regressor, and we also tried k-means and a 5-layer neural network that is not pictured. After careful thought, we decided to proceed with our project with linear regression, considering the results were fairly good and we thought it would be a good fit for our model in our particular dataset and what we were trying to achieve. We were curious to manually see first how well the model is predicting Airbnb prices. So given 3 scenarios with different client preferences, we collected some information to try and answer some of our research questions. For instance, client 1 had the highest Airbnb price because they were looking for one in a popular neighborhood, Manhattan. They were also looking for a recent entire room, which is more expensive than a private or shared room. We also noticed that when the availability is fairly high, or in other words, not many people have booked it, it could have something to do with the fact that it's more expensive, so many people would skip it and try to find a more cost-saving option. Similarly with client 2, it had many bookings and it was also a private room, which resulted in a lower price. And client 3 was similar to Client 1, except less availability again, and had more reviews, so there was a slight decrease in price. Now moving on to the cloud portion, where now that we had a stable model, we could integrate it into the Google Cloud platform. So the app is hosted on GCP, and to develop our application, we use Flask for the back-end portion, and for the front end, we use HTML and CSS. To make our application interactive, we decided to implement a navigation bar, stylistic button to navigate to the prediction page, and a form that users and clients can use to input information based on their preferences for their Airbnb. So I can go ahead and show the application that we implemented. The user is welcomed with an image, and they click on Predict Airbnb Price. They will be navigated to a form with a text typing option and a drop-down menu option depending on the feature. So let's say that I'm a client and I want to have a neighborhood group in Manhattan. In any neighborhood, you want an entire room, 43 reviews, let's say 1.6 reviews per month, available for 252 days out of 365. And this is the predicted price for the user, and it will automatically come for their desired Airbnb. Now going back to our research questions, we realized there were many efficient model options for us, including random forest, gradient boosting, and decision tree, but we decided for our project just to go with linear regression. As far as patterns, we noticed that the value of reviews per month increases, the price increases as well. One major assumption is that usually a poor experience leads people to want to express that in a review. Maybe many times if someone was satisfied, they don't leave a review as often. We also noticed that availability for the year is that as the price increased as well as the availability increased. We assume that if an Airbnb price is considerably high, individuals may continue searching for a more cost-saving option instead. With that being said, we have learned a tremendous amount of concepts in this project and throughout this course, and this validates how machine learning coupled with cloud computing can be and is applied to endless amounts of real-world applications. Thank you so much to our professor for being a helpful guide this semester. This concludes our presentation, and we hope you enjoyed.